two for like 8 plus minutes. Let's verify the connectivity over to this network using the ping command. Let's ping over to 192.168.2.2, and it is successful. So I can reach this BGP learned network or prefix. So now we have configured a neighbor relationship between router 1 and 2. We injected BGP network inside our BGP database. BGP also has multiple tables. Table for neighbors, table for database, and then best paths will be delivered to the routing table to be installed, just like almost like other routing protocols we know of. Let's configure router 3 to have neighbor relationship with router 1 and router 2. Just a few other options. Let's go over to router 3, and from the global configuration we're gonna use the command router BGP autonomous system 13. We're gonna specify the neighbor command to have neighbor relationship with router 2 remote -AS2, and we're gonna have internal BGP between router 1 and router 3, and now the neighbor relationship between router 2 and 3 came up. I need to configure router 1 to have neighbor relationship with router 3. I'm gonna copy this command over to router 1 and specify 13.3 as the IP address being used to establish BGP neighbor relationship. Now on router 1, if I'm gonna use show IP BGP command again to view the database, okay, you guys can see that for the network 192.168.2.0 we have 2 paths. Okay, one of them is internal. Okay, we agreed that on the left we have status codes, and I means internal. Okay, internal, as we agreed, means that it has been learned through iBGP neighbor, which is router 3, and we have another path which is better, okay, through router 2. Okay, so now we have 2 neighbors that are sending the same prefix. Of course, router 2 injected information about this network right here into BGP and sent information over to router 3 and to router 1. And because router 1 and 3 are BGP neighbors or have BGP neighbor relationship, router 3 sent information over to router 1, but for some reason router 1 prefers information received from the external BGP relationship, which is true by default. Okay, this is normal behavior of BGP. So injecting routes into BGP, as we saw, is simply could be done using the network command. Okay, but the network has to be in the routing table, otherwise BGP will advertise nothing. Okay, so you could be using this form of the command specifying the mask, or you can just specify the IP address and not the mask, and accordingly BGP will assume the default. Okay, so let's make sure that BGP will only use the command the way we agreed. So let's get back to our design, and down below at router 2 we have a network called 172.168.0/24. This network right here has a mask of 24 and it has a subnet. So what will happen if we are to advertise this network using this command, network 172.16.00 mask 255.255.00. Okay, this form of this command is acceptable, but will it achieve what exactly we want? Will this command advertise the network called 172.16.2 on router 2? No, it will not. Okay, unlike we use the network command in OSPF or EIGRP, BGP is kind of different in a way that it looks for exactly the network in the routing table. So we have specified that we need to advertise 172.16.00/16, so it will search for this /16 network and nothing else. So let's just use this network command and let's view the IP routing table on router 2, and as you can see we have 192.168.172.16.2 we do not have 172.00/16. So this command we've just used will not advertise anything on router 2. To verify that, let's view the database, show IP BGP, and yes, this is the command we have used, and it says that we only advertising, or actually in our database we only have this network right here. And if we are to verify that on other routers like router 1, show IP BGP, again we do not see any information about the network called 172. So we either on router 2 use the exact IP address of the network, or if we want to advertise a summary we could be doing summarization, and we're gonna be talking about summarization in BGP in the upcoming lesson, but for now we can be doing this. We could install a summary route, for example, or actually a static route on router 2. Let's do this. Let's add a static route on router 2 that points to 172.16.00/16 to the null 0. Okay, this way on router 2 we're gonna have a route to the 172.16/16 network. To verify this, we're gonna show the IP routing table, and now we have a static route that points to the /16 network. This way BGP will find a route to advertise, because actually we said that BGP will look for an exact match for the IP address we specified in the network command. So now router 2 should be advertising 172.16.00/16 network using BGP to other routers, because actually now we have route in the routing table specifically matches the network command. And to verify this, we're gonna use the show IP BGP command, which shows the database, and it says right here we have this prefix 172.16.00, and it has no prefix length like /16 or something. If you do not see any prefix length specified after the IP address, this means that actually this is its default prefix. So 172 is actually a class B network, so normally it is /16, and it's not mentioned because actually it is assumed by default. If you see a prefix that has next hop of quad 0, this means that this prefix has been originated on this router. So we are the next hop, okay? And we have no path whatsoever. We do not have any autonomous systems, okay? Actually, by the way, this is the weight value, okay? And this is the I code, which means that this prefix has been inserted or installed in the BGP table using the network command. IGP means that this prefix got into the BGP database using the network command, and this is exactly what happened. We're gonna see other ways to inject routes into BGP database to be advertised over to other BGP peers in a bit. So to verify the receipt of the update at router 1, we're gonna use the show IP BGP, which actually shows the database, and again, indeed we see a route to the prefix 172.16. We have two paths. One of them learned through an internal BGP relationship or neighbor, and the other one came from other neighbor, and it is considered the best. Okay, so this is one solution for not having the exact network we are trying to advertise in our routing table. For example, router 2 wants to advertise the whole 172.16 range, and it has only the 172.16.20/24 network right here. So to advertise this, we could be just adding a static route on router 2 pointing to wherever, to nowhere. Actually, null 0 means nowhere. Okay, and using the network command, we could be advertising this over to other BGP peers. So this is one solution.